For this one, we have a piecewise function, so it tells us that this function is the answer every single place on the entire graph except for when x equals 2. And then when we're trying to figure out when x actually does equal 2, what would the function equal in order to make the graph continuous? So remember, in order for it to be continuous, whatever the limit is going towards, there's a three-part definition of a limit. The limit must exist, the function must exist, and the limit must equal what the function equals. So once I find out what the limit equals, I can just make k equal that value, and that way the function will equal what the limit does equal. So I just need to figure out the limit of what this equals. Notice that I have some square roots, so you guys need to think about that trick that we learned about square roots, that whenever we have a square root in a fraction, it's the only way you know how to do it, and honestly on every single AP question that you will ever encounter, the way that they will always present it is to multiply by the conjugate. So if I multiply by the conjugate, I get the square root of 2x plus 5 minus the square root of x plus 7 all over x minus 2. And if I multiply by the conjugate of that, I get the square root of 2x plus 5 plus the square root of x plus 7 divided by that same thing, square root of 2x plus 5 plus the square root of x plus 7. And again, I'm allowed to do that because that's just a factor of 1. So on the top, this is a difference of squares now. So notice that when I multiply the first terms, the square roots are going to cancel. So I get 2x plus 5 times 2x plus 5 underneath square roots. So the square roots cancel, and I'm just left with 2x plus 5. Notice that my middle terms are going to cancel. One of them is going to be the positive multiplication of these square roots, and one of them will be the negative multiplication of these square roots. So those two will cancel each other out. And again, that's the point of multiplying by the conjugate, is that you want them to cancel each other out. And then when I multiply the last terms, I get a negative square root of x plus 7 times the positive square root of x plus 7. So that's minus x plus 7, and the square roots will cancel each other out. On the bottom, never, ever, ever multiply anything on the side that doesn't have the square root part that like cancels itself, because it's not going to help you. So just leave it factored out like this, because you'll see in just a minute that that top is going to disappear for us. So if I simplify the numerator, I get 2x minus x once I distribute that negative. So 2x minus x is just x. And I get 5 minus 7, which is negative 2. And voila, look, that x minus 2 on the top is going to cancel with that x minus 2 on the bottom. And I'm just left with 1 over the square root of 2x plus 5 plus the square root of x plus 7. Again, that's the only way you've ever learned how to do this, and it's the only way that you'll ever see it on the AP Calculus test. So anytime you're trying to find a limit of a function with square roots in it, and it's like this, like a fraction, always multiply by that conjugate, and it will always work out that it cancels out. Of course, like in the realm of mathematics, there are other ways it could work out, but in the class that you are taking right now in calculus, this is the only way it's going to work, because it's just the only technique you know how to do with the knowledge that you have so far. So keep that in mind, that you should always go towards that when you're trying to find the limit of a fraction with square roots in it. So at this point, again, I'm trying to figure out at the breaking point what the limit's going towards. So far I haven't changed anything in the equation. I've just manipulated the way that it works, or the way that it looks, I should say. So now I need to evaluate this, whatever's left over, when x equals 2. And again, the reason I couldn't do that from the beginning was because every time I plugged in 2, I kept getting undefined. So it wasn't until I could cancel out that x minus 2 factor, and now I don't have an undefined in my denominator anymore. So now I can plug in 2. So I get 1 over the square root of, and I'm just going to do this in my head if that's okay with you guys. If I plug in 2 here, I get 2 times 2, which is 4, plus 5, that's 9. If I plug in 2 here, I get 2 plus 7, that's 9. So I have 1 over the square root of 9 plus the square root of 9. And if I simplify that, I get 1 over 3 plus 3, which equals 1 over 6. So that answer choice is B.